Welcome everyone to this lecture on the collections module. The collections module is built into Python in base Python, and it implements specialized container data types that are essentially alternatives to Python's built-in containers that are just general purpose. So what I mean by a container is something like a dictionary or a tuple. We've already learned how to use normal dictionaries, but Counter has specialized dictionary objects or specialized tuple-like objects. So we're going to learn about these specialized container types. You may not always need these specialized versions, but in certain use cases, you may find them useful. Let's go ahead and open up a notebook. All right, here I am in the Jupyter Notebook. The first object I want to show you from the collections module is the counter class. We will import it by saying from collections, import, and then capital C, counter. Let's imagine you have a situation where you have a list and then some unique values in the list, but there's also repeats for these unique values. So I'm just going to make a bunch of 1s, a bunch of 2s, a bunch of 3s, and so on. Now let's imagine I wanted you to get a count of each unique item in this list. For example, I want you to count how many 1s are there, how many 2s are there, how many 3s are there. Well, you currently do have the skills to do this. You'd probably have to create a for loop and then have some sort of dictionary keeping track if you've already seen the number or not. And then if you've already seen it, go ahead and add +1 to the count. If you haven't seen it, create a new key and then add 1 again, etc. So that's actually quite complicated, but Counter can do this for us automatically with a single call. It's super useful in these sort of situations. Simply pass in my list into Counter, and then you get this specialized counter object that has now counted the instances for each unique item in that list. So there's 5 instances of 1, there's 4 instances of 2, and there's 7 instances of 3. And this works if there were strings as well. So let's imagine we have some A's there, and then let's say 3 10s. I'm going to say counter my list, and I can see here it counts that there's 2 A strings and then 3 instances of 10. Notice this looks very similar to a dictionary, and counter is technically a dictionary subclass that essentially just helps count hashable objects. So inside of it, elements are stored as dictionary keys, and the counts of the objects are stored as the values. So kind of this specialized dictionary where the keys are always the object, and then the value is always the count. Now this also works with strings, so I could say counter, and then pass in some sort of string. So let's say AAA, BBB, etc. Run that, and it counts the individual letters. Let's imagine I wanted to count the words in a sentence. Well, I already know this works with lists, so I could split the actual sentence. So let's create a sentence here saying how many times does each word show up in this sentence with a word, or something like that. Well, I know I can simply split this string on the white space to get a list that looks like this, which means I can then call counter on that list, and now I have a count of each word. And I see here words showed up twice. And if I wanted to, I could do something like call lowercase on everything first, then split it in case I wanted to check for capitalized versions. So finally, let's go ahead and show you some common patterns that we will encounter when using the counter object. I will say, let's say letters is equal to a string. Go ahead and put some A's in there, some B's in there, and let's put a bunch of C's and a bunch of D's. There we go. And I'm going to create my counter object. I will just call it C. Notice now I'm actually assigning counter to the result here. And so I check out C, and it tells me the counts. So notice there's 3 A's, 4 B's, 8 C's, and 11 D's. I can do C.tab. You'll notice there's a bunch of methods that look very similar to methods that we already know are available on dictionary, like keys or values, but there's also things like most common. So most common will actually just return back the most common here in a list as a tuple. So it says D is the most common with 11 instances, C is second most common with 8, B third most common with 4, A fourth most common with 3, and it would keep going. And it's up to you to provide here a number, n, of how many you actually want returned. So let's say I wanted the 2 most common, then it would just return D and C. If I wanted the 3 most common, then it returns D, C, and B, and so on. And we've actually provided for you in the lecture notebook that goes with this. Just going to bring it in over here. If you scroll, there's a common patterns when using the counter object. It's essentially a little table here that shows you just things that are common to do, like get a list of total of all counts, reset all counts, list the unique items, convert to a set, and so on, and then the actual code you would use in order to do that. So let's go ahead and try one of these out. Let's imagine I want to list unique elements. Then all I have to do is take my counter object, which you notice looks kind of like a dictionary here, but I can actually pass this into a list, and then I essentially just get a list of all the keys, so all the unique values. Lots of different things we can do with the counter object. Obviously, it's really designed to be this workhorse for the case where you have to count unique elements. All right, we have two more things to show you from the collections module. The second one I want to show you is the default dictionary. So we'll say from collections, import default DICT dictionary. And what we're going to do here is show you what happens in a normal dictionary, and then we'll show you what happens with a default dictionary. I'm going to create a dictionary, quite simple, has the value A, or excuse me, the key A with the value 10. So I check out this dictionary, A to 10, no problem. And if I call the key A, it returns back 10, as expected. But in a normal Python dictionary, let's imagine I call the wrong key. So notice wrong, definitely not a key yet in this dictionary. If I try that, it's going to complain saying, hey, key error, this doesn't exist within this dictionary. In certain situations, especially when you're doing something like a for loop that you want to quickly add in keys that are not already present in your dictionary for whatever particular reason, you can use a default dictionary. And what a default dictionary does, the way it gets its name, default dictionary, is it will assign a default value if there's an instance where a key error would have occurred. So essentially, if you try to ask for a key that isn't present in a default dictionary, it will assign it with some default value. Let me show you how you can create this default dictionary. And the way we do this is by saying whatever your dictionary is going to be, so we'll call it D again. In this case, we call it default, DICT, for default dictionary, and we have to choose what the actual default value will be. So instead of returning a key error, it'll assign it our default value. And we can do this through the use of a lambda expression. So we'll simply say lambda, colon, and then whatever you want the default value to be. For instance, let's say I want all the default values to be 0. So it still behaves like a normal dictionary under normal circumstances, where I can assign some key. So let's say this is a correct key. I'll assign it the value 100, and if I call it again, it turns back 100. But now, let's put in a key that we know is not currently present. So in a normal dictionary, this would result in a key error. But maybe you have a situation where you want your script to keep running and you want to assign some default value, like 0. So when we run this, notice we don't get that error anymore. Instead, it's automatically assigned it this default value. And now when I check out the dictionary, I see it's a default dictionary. It reports back that it has this lambda function here. That's what this is, or a lambda expression. And then we have the wrong key, 0, correct, 100. So hopefully you can see the various use cases for a default dictionary. Perhaps you're trying to assign values to a dictionary, but you don't know if everyone's present or not. So maybe you just have a default value of 0 for them if you encounter them and don't have them in the dictionary yet. Okay, so that's the default dictionary. The last specialized container object that I want to show you from the collections module is called the named tuple. So similar to the way a default dictionary tries to improve on just a standard dictionary by getting rid of this key error with a default value, the named tuple tries to expand on a normal tuple object by actually having named indices. So let me show you what I mean by that. Let's create a standard tuple. We'll say my tuple, and it's just 10, 20, 30. So this is a very small tuple, which means if I wanted to grab, let's say 10, I know I can see it's at index 0, and there we have 10 returned to us. So I just need to look up the index, pass it in, and then there's 10. Now, in certain situations, you may have a very large tuple, or you may not remember which value is at which index. So the named tuple is going to have not just a numeric connection to the values, but it will also have essentially a named index for that value. So instead of just calling it by 0, we could call it by some sort of string code. Let me show you how we can construct a named tuple. It actually kind of looks a lot like a class. So we'll say from collections import named tuple, and let's construct our named tuple, which is almost like constructing a new object using object-oriented programming, or OOP. So we'll say dog, note there's no parentheses here, is equal to named tuple. And there's two main parameters, which is the type name, what type this will be reported as, and then the field names passed in as a list. So let's go ahead and say that the type is going to be a dog, and then a dog will have an age, a breed, and a name, almost like attributes in a class call. And now I can create instances of a dog object. So note dog here, and what I'm going to do is create a dog called Sammy, and then I'm going to say that Sammy is 5 years old, the breed is a husky, and then the name is just Sam. So we have this variable Sammy. If we check the type of it, notice it reports back that it's type dog. It doesn't report back that it's a named tuple. So if I take a look at Sammy, notice it looks kind of like a mix between an object you would have created with object-oriented programming and a tuple itself. So essentially, it's kind of like this tuple here where you had 10, 20, 30, but notice now there's essentially an association with each value. So it's age for 5, husky for breed, name for Sam, which means I can call these by saying Sammy dot age as if they were just attributes on this. So then I can call for the breed, and then I can call for the name. Now notice if I say Sammy at index 0, I get back 5, which was the same thing as calling Sammy.age. So you can imagine for very large tuples or tuples where you can't quite remember what value is at which index, it might be useful to be able to access them both by calling an index position, such as 0, or by calling it as if it was an attribute, asking for the age. Alright, so that's it for this lecture. You can check out the full documentation online on the collections module. These aren't things you're going to use for every single Python script you ever write. However, there may be certain situations where these can really help you and are more of a convenience for you. So you can check out the full docs online, and I will see you at the next lecture.